their fault. All right, so here we go. Let me change this to dark and let's start over. Oh. Scientific notation is placing the decimal to the right of the first number greater than 0. That's a Hubertism definition. Hubertism definition means that I made it up. And when did I make it up? When I was a student. Because I never could figure out what the heck they were talking about doing all that. A format in which a number is expressed as a number between 1 and 10 multiplied by power of 10. That doesn't make any sense to me. All right, so when I was a student, I just did this. Placing the decimal to the right of the first number greater than 0. How do we read numbers? How do we read sentences? From what? Left to right. So 134,000. And 0.0000327. Where is the decimal on both of these numbers? On a whole number, the decimal is where? At the end. It's never seen, but it's right there. On a decimal, it is seen. It is right there. So if you want to change these two, whole number notation and decimal notation, if you want to change them into a scientific notation, the first thing you need to do is establish where to put the decimal. We all read from left to right. We all read from left to right. So where is the first number greater than 0 on the 134,000?
The 1.
The 1. So you're going to put the decimal right there. Where is the first number greater than 1 on the decimal?
3.
Simple as that. Now that's the first thing you have to do. The first thing you have to do with scientific notation is where is the decimal, where do I put the decimal? That's the first thing. Then you have to count. 1, 2, 3, 4, 5. You count 5 places. Did I say anything about direction? No. I didn't say anything about direction, so you don't need to worry about the direction. I'm going to move this one. 1, 2, 3, 4. So I moved 5 places over here, and I moved 4 places over here. Question. Now remember, this is the definition I used as a student, and I've done the first part. The first part is to put the red dot where it is. The second thing is to move to where it fits the definition. We read from left to right, so that means 1.34 and 3.27. Now we're going to move to the next part. The next part, and I'm going to make this, I'm going to have to move this. Let's see if I can move it. Okay, it's not going to let me because I'm on transparency. So we'll just go backwards and I'll do the next part. I'm going to write it in black and I'm going to say 1.34 times 10 to the blank 5. Okay? And 3.27 times 10 to the blank 4. Now, why did I put blank 4?
Well, because you don't know if it's going to be positive or negative.
You got to put a positive or negative. Now, this is where I do a little bit different from other teachers. This is where I'd say right here in my blue. Let me get another blue. I'm going to take blue here. And I'm going to draw this blue dot here. And I'm going to go over here and I'm going to say, which way mentally? Mentally means what? Yeah, some people have different definitions of mentally, but mentally here means in your head. You need to think this. Which way do I move to get original? Okay? Right now, this decimal is here in my head. Okay? Which way do I move it to get it back the way it was? To the right. So if I move it to the right, it's what? Positive. If I move it to the left, it's what?
Negative.
A negative. Now, this helps when we're working with problems where you multiply and divide. Okay? Because 90% of y'all, 90% will be able to do this without any problem. Okay? That's not where the problem comes in. The problem comes in when you actually have to do, hold on just a second, let me get out of this and move to the whiteboard. Give me a second. Here is where you run into problems. And let me use a black. I don't have posters. Sorry about that. Just use this technology here. All right, so I've got 3.0 times 10 to the 5th times 15 times 10 to the 6th. Okay, now this is where you run into problems. You run into problems because a lot of people, they use the patternization that people give them or teachers give them, and they think, okay, I've got to move to the left, got to move to the right. You don't need to do any of that. The first thing you need to do when you do one of these, division, multiplication, is break it up. 3.0 times 15 times 10 to the 5th times 10 to the 6th. Okay? So what did I do? I took the two numbers, dang old highlight. I took those two and put them right here. And then I took, dang old green highlighter, take these two numbers and put them here. Question. Now, you don't have to be a rocket scientist to multiply 3 times 15. 3 times 15 is what?
45.
45. Thank you for interaction. 45 times. What is significant about these two? You have the same what? You have the same base. When you have the same base and you are multiplying, what do you do to the exponents? You add them. So that would be 10 to the 5 plus 6. So now we've got 45 times 10 to the 11th power. Are we done? No, we're not done. Why? Because it's not in scientific notation. Why is it not in scientific notation? Because the decimal is right here, and it needs to be where?
Beside the 4.
It needs to be beside the 4 because of our definition. That's where it needs to be. So we got to move it in one place. So then you go over here and you say, well, I got to move it. So I'm going to go yields 4.5 times 10 to the 11 blank 1. I moved it one place, didn't I? Where'd Mr. B go?
Probably bathroom.
When did he leave? I didn't see him leave. The Russians got him. All right, so which way do I move this decimal to get it back the way it was?
Right.
To the right, so that's a positive. So our answer is 4.5 times 10 to the 12th power. Now let me talk to you for a minute. 90% of the students that do this problem, basically 90%, will do all of this correct. what will they get wrong? The
Moving
last
the decimal.
step, and they'll get a 10 right here. Okay? That is the number one mistake that students make. They get all of this right, and then they get down to the bottom, and they get right here, and they say to the 10th power, because they don't know how to do this right here. Okay? So let's take a red highlighter, since I don't have posters. Let's highlight that, and let's make that extremely, put that in your notes, and say, be careful. All right, let's do one that's a little bit different. Let's do one with division.
I have a question.
Yes.
So how would the 15 be a 15 instead of 1.5?
That's just the way they give it to you. Sometimes they give it to you. I'm just
That's what I
making
was
this
trying to
problem
figure
up. Sometimes they give it to you like this just to see if you know what you're doing. And sometimes it's considered a trick question. Most of the time, that's going to be 1.5 times 10 to the 7th. But sometimes they will throw in like a standardized test. They'll give you a question and have 15 there, and they'll have 3.0 over here, just to see if you know what you're doing.
So theoretically, could we go ahead and move that? and
You
just
could,
end
yes,
up
you
with
could.
that?
But then you'd have 3 times 1.5, and what will you do there? You'll have an anxiety attack because you have 3 times 1.5 and you don't have a calculator. You do 3 times 15 in your head a whole lot easier than 3 times 1.5.
Okay. Yeah, I was just trying to figure that out.
I'm just saying that sometimes, you know, when you're given this, you need to go with it and then do the change down here.
Okay.
Because you know what 3 times 15 is. That's 45. Now, you could also say, well, 3 times 1.5 is 4.5. Yes, you could do that also. I'm just showing you where students mess up.
Right.
Students mess up right here. Okay? On that last step, that's where they mess up. So let's do a nerd. Miss Riddle, you with me?
Yes.
Okay. Miss Annie Sador, you awake?
Yes.
Okay. Mr. B, he left. You know what happened?
He got frustrated.
No, Russians got him. Threw him in a van, beat him up. All right, so here we go. Let's do 45 times 10 to the 12th divided by 3 times 10 to the negative 6. What's the first thing you're going to do? Separate it. So I'm going to take this, wrote it in the, let's take this and move it over here, and let's make it a little bit smaller. There we go. And we're going to break it up. 45 divided by 3 times 10 to the 12th divided by 10 to the negative 6. And I'll take my handy dandy highlighter and I'll highlight these two. And that's right there. And then my dang old birthday. Is it birthday?
Yeah.
Come on, say this is Espanol. Ten dang old birthday. All right. And now do the math. 45 divided by 3 is 15. Times, now be careful here, what are you supposed to do when you have the same base and you are dividing?
You subtract.
Subtract 12 minus a negative 6. What's the most common mistake students make here?
They try to...
They say, well, there's a negative 6 there, so we'll just put that in there, and they get 12 minus 6 is 6.
You gotta add them.
And they get it wrong, yes. So, 15 times 10, and we'll take our handy dandy, dang old magenta, and we will put a BA plus right there. And what is 12 plus 6?
15.
Now, finish the final answer because you're not done. Where is the decimal right now?
Behind the 5.
So you got to move it. So I want y'all to move it. Take a minute and move it. How many places?
Just one.
One place. So you did. See, I'm not even talking about a direction yet. 1.5 times 10 to the 18th blank 1. Which way in my head do I move this decimal in my head to get it back the way it was?
To the right.
To the right. 1.5 times 10 to the 19th power.
So are these questions that are going to be similar to the ones that are on the test?
Yes.
Okay.
These are the questions that I like to test people on. Multiplication and division. Because that's the one students miss on entry exams, nursing exams, GRE exams. These are the ones you miss. These are the ones that you don't miss. Hold on a second. These are the ones you don't miss. 0.000567 and 12,432,000. Those are the ones you don't miss. Everybody gets those right.
Yeah.
Let's do this one. 1, 2, 3, 4, 5.67. Oops. Times 10 to the 4th. And which way do you move this decimal to get it back the way it was in your head? To the left, so that would be a negative. Here's the decimal here. 1, 2, 3, 4, 5, 6, 7. 1.2432 times 10 to the blank 7. Which way do you move this decimal in your head to get it back the way it was? To the right. And I can give you one like this, and you'll get it right. 2.56 times 10 to the 4th. And 3.14 times 10 to the negative 2. Well, what do you do here? You rewrite 2.56 and you move 4 places to the what? It's positive, so that means right. 1, 2, 3, 4. So that's 25,600.
Wait, what? Oh, you just changed it to a positive? Okay.
Yeah, it was a positive. Oh, I'm sorry. It is a negative. My bad. I suck. Hold on. It's supposed to be a positive. Oh, I don't know where that came from. Erase that. There. Because this one's negative. All right? So, 3.14 times 10 to the negative 2, you rewrite 3.14. And you move what? 1, 2. So again, these are the 4 type questions that most students don't miss on the test. Okay? But when they give you...
That top one is supposed to be negative. The bottom one's supposed to be...
Yeah.
Yeah.
What?
The top one is supposed to be negative. You change the top one to a positive and it's supposed to be a negative.
Oh, I thought I was doing this one. Okay. Oh, okay. That's okay. Thank you. I thought that one was that one. I'm sorry. Okay. You did that, Miss Porter.
No.
Yeah, you did. I'm not supposed to take credit for making a mistake. You're supposed to blame it on somebody. Remember? Blame it on other people. Right, Miss Riddle?
Yes, always.
I think Mr. B, I'm worried about Mr. B.
He's back, I think.
Mr. B, are you back?
Yeah, I'm absolutely back.
And the Russians, they didn't hurt you, did they?
No,
Okay. They make you do anything you didn't want to?
not really.
Okay, good. All right, look here. Those are the ones. That's the one. That's the one that gets you. Now, let's do one that you might also see on a standardized test or on my test. 2.0 times 10 to the 5th plus 4.0 times 10 to the 5th. What's good about these?
They're easy.
They're easy. You don't have to do anything. But don't think too much. Okay? What do you do when you add or subtract and they are like terms? Let's take our handy dandy green highlighter and let's highlight these right here, and that can be a plus or a minus. Now, what's 2 boxes of cereal plus 3 boxes of cereal?
5 boxes of cereal.
So the label doesn't change, does it?
No.
So the 10 to the 5th is not going to what?
Change.
That's your boxes of cereal. So that's 10 to the 5th.
That makes sense now.
And what's 2 plus 4? You might want to use your calculator.
6.
Now, if these two are different, you got a whole different animal. If those two are different, you've got to change them into decimals. There's no shortcut to doing this type problem if it's different. If those two are different, you're going to have to write it in terms of decimals and do it the old-fashioned way, add them longhand. Okay, let's do a nerding. Oh well, let's change this to, oops. Let's change that to the 7th power and that to the 7th power. So we highlight these two and we're subtracting, but you still highlight these two because they don't what? They don't change, Hubert. Thank you for the interaction, y'all. 10 to the 7th. And what's 15 minus 9?
6.
And you're done.
Can you do one where the
They're
power
different?
is, yeah.
Okay. Oh, me. Y'all make me do so much extra.
Sorry, Hubert.
Well, I'd rather see it in class.
No, the whole point is, golly, why y'all want to better yourselves? All right, 2.0 times 10 to the 5th plus 4.0 times 10 to the 4th.
Why can't you just add them and it'll be fine?
There ain't. Nope. You got to change this one to a regular number. So 2.0, 1, 2, 3, 4, 5.
Oh, this sucks.
Well, I'm sorry. And 4.0, 1, 2, 3, 4. So you've got 200,000 minus 40,000, and now it's easy because these three come what?
Straight down.
Down. And what's 20 minus 4?
Plus 4.
16.
Oh, sorry. 20 plus 4, sorry. 20 plus 4 is 24. Lisa, you're messing me up. 24, so 240,000.
And then you would put it back in scientific.
Yeah, now you put it back in scientific notation because what do we start with? What's the general rule of science and math? Whatever you start with, you what? End with. Scientific notation, regular notation, not good enough. 1, 2, 3, 4, 5, Sink. Is it sink or set? Sink.
Cinco.
So 2.4 times 10 to the 5th. And which way do we move this in our head to get it back the way it was?
Right.
So our final answer, since we started with scientific notation, is 2.4 times 10 to the 5th.
And when you subtract them, you do the same thing, right?
Mm-hmm.
That's not terrible. See how that'll
No,
be a lot worse than that.
it's always best to just write it out. But when you get to multiplication and division, you get into a mess because you got so many zeros to multiply, and it's just a mess. So I would not suggest doing this with other stuff. Okay? Question, gripe, complaint. Now, another thing that goes with scientific notation are those things that y'all can't do and should quit and not do and just skip them, right? What are they called?
Yeah.
Starts with a W or W, depending on where you're from.
Word problems?
Word problems. So what do we do to word problems when we get to one on a test?
We skip it.
Skip it. Good job. Never try to better yourself. Here we go. 2 planets are 250 million miles apart. you have a spaceship that can go 3,500 miles per hour. How long would it take for you to travel from planet to planet? Distance equals rate times time. I'll even give you the formula. So, two planets are 250 million miles apart. You have a spaceship that can go 3,500 miles per hour. How long would it take you to travel from planet to planet? Well, first of all, let me ask you a question. Your car, you usually travel 60 miles per hour on the interstate. And you want to go somewhere that's 500 miles away. What do you do to find out how much time it's going to take you to go to that place?
Wouldn't you just divide?
Okay, let's look and see. What is D? Distance, Hubert. That's right, class. What is R?
Rate.
Rate. Do not say this in physics class because the physics teacher will have a conniption, but that's speed, okay? Don't say that in physics class because they'll have a heart attack, okay? And what is T? Always, what is lowercase t? Time.
Time.
So let's solve this formula for T. What are you going to do? How do you get rid of multiplying by R?
You divide.
By R on both sides. So D divided by R is equal to T. So Miss Riddle, you were correct. You're going to divide the distance by the what?
Rate.
Speed. Or, yeah, rate. Let's say rate. Okay? We don't want to have anybody have cardio infarctions. Okay? So, let's divide 250 million. Let's divide that by what?
3,500.
Good job. Do it. If you can't, then that means what? What does that mean?
We need to quit.
Yep. 250,000 divided by 3,500.
I got 71,428.
Well, hold on a minute. Did you do scientific notation?
Wait, maybe. No.
No.
You said 1,000.
I just did it in a calculator. That's why people can't make change and can't spell mom backwards.
Hubert, I told you I
3,500.
can't math.
What was that? Was that a phone?
Yeah, that's my
I'm
phone.
supposed to have a heart attack. Throw you out of the room, Mr. B.
Oh my lord.
Okay, so I'm going to change 1, 2, 3, 4, 5. 2.5 times what?
10 to the,
Yeah.
yeah,
Over 3.5
over 10 to the
times 10 to the what?
third.
Now, I'm not Rain Man, so take 2.5 and divide it by 3.5. What do you get? I'm sorry, I can't hear mumble.
0.72.
0.72. Everybody get that? I need a second.
I got 0.71, but close enough.
Okay, 0.72, 0.71.
Around it.
Times 10 to the what is 5 minus 3?
2.
So 72, move 2 places, 72 hours to go from planet A to planet B. This is your distance. This is your rate. And you're given time. Now, why did I turn it into 72? Why didn't I change it into scientific notation? Because what did we start with? Whole numbers or scientific notation? You started with regular notation, so you end with regular notation, unless otherwise specified by the instructions. So 72 hours it would take to go from planet A to planet B, which is basically what? Dang old 3 days? 24, 24, 24. What's 24, 24, 24? 96? Or is that 86? 76. What is 24 times 3?
72.
Okay, 72. Okay. 3 days.
72.
And you're actually flying because you're going 3,500 miles per hour. It's kind of unthinkable, but that's what you're doing. Miss Riddle, what time is it before y'all go into convulsions?
9:53.
Okay, we're going to have to go. We'll stop it here because I want to spend most of our time on, what is this, 2B?
This is 3B.
3B. 3B is going to make up around 70 to 80% of your test. Why? Because after what we've gone over in the last week and a half, it's going to be the most applicable to any of your standardized tests, your entry-level test, or my test. So that's why we're going to spend a lot of time. We're going to spend at least Friday and Monday on scientific notation. So make sure y'all send in your questions, and I'll get to your question Friday, okay?
That's fine.
Send in your questions. Miss Porter has sent in a question from what, 2A or 2B?
2A, I think.
2A. And I'll go over any questions that y'all send in. We'll start those questions Friday. Anyone got questions for me? All right. Y'all have a good day. Keep between the ditches. And I will put this on YouTube. So y'all can watch it over and over and over for the one person that does that.
I did watch.